Okay, we're gonna add another change to our changes to the parent function on this one. So I'm gonna have you guys actually turn these in. So you're gonna turn them in at the start of class. Make sure you just write the changes to the parent functions. So you'll notice that all of these have a number in front, and we didn't do that before. The rest of it you already learned, so that should be pretty simple. So what we're gonna look at is we're gonna add another term. And the term out front is kind of like your slope. So if I think about a quadratic parent function, looks like this. Y'all learned a lot about quadratics in algebra 1. If I make it negative, you guys probably know that what that does is it flips it over. So now it's going to be coming down this way. So the only change to this is that it flipped across the x-axis. And the way that we say that is we say it's reflected across the x-axis. Now that's a lot to write, so we just abbreviate it as reflected across x-axis, okay? So when you see that, it means reflected across the x-axis. I'm fine with you guys writing this, but you need to say reflected across the x-axis, okay? Now if I change it so it says this, that's like a slope. It's not technically the slope, but it's like a slope that's 3 times bigger. So you know that when the slope gets bigger, it gets steeper. So what's gonna happen here is instead of being like this one, it's gonna be really, really steep. It's gonna be like this. And what we say that happened here is I grabbed it vertically and I stretched it, and that made it really skinny. So we call this vertically stretched by a factor of 3. Now again, that's a lot to write, so we'll put vertically stretched by a factor of 3. All right, so I can do a reflection and a vertical stretch at the same time. Now if I put it so it's like you know that when my slope becomes 1/2, instead of looking like this guy right here, what's going to happen is it's going to get wider. So that's like I took the graph and I pushed it down or compressed it. So we would say it's vertically compressed by a factor of 1/2. So that's a lot to write, so I would put vertically compressed by a factor of 1/2. So that's what we're doing here. So when I have ones that look like, it doesn't matter which parent function I have. This is going to vertically stretch it by a factor of 3. This is going to move me to the left 2, and this is going to move me down 9. If it tells me this is going to vertically compress me by a factor of 1/4. This is going to move me to the right 1, and this is going to move me up 7. So that's what we're looking at today.